Now the question is this a perfect square trinomial? Welcome back to another math video. Today we'll be talking about factoring perfect square trinomials. One of those terms that will pop up in our discussion is binomial. Now bi means two and nomial means terms. So binomials are just expressions consisting of two terms. Another term is trinomial. So similarly, tri means three, nomial means term, so it's just three terms, an expression consisting of three terms. We also have polynomial, poly mean many, so it's many terms. Now, before we dive into factorizing perfect square trinomials, so we know that factoring is the reverse of expansion. So let's look at this binomial right here, a plus b all squared. And we know that this is just saying that we're multiplying a plus b by itself. We will get a squared plus 2ab plus b squared. Another one is a minus b all squared. And let me just point out that a and b can be any term. And we would get a squared minus 2ab plus b squared. So we have just expanded both of these binomials, but we could flip this around. And if we were given these trinomials right here, we could get them in the form of the binomial squared. So these are classified as the formulas, and these are what we will use to guide us to make factoring perfect squares much easier. Here asks to factorize x squared minus 20x plus 100. Now, there are several factorization methods. So we could use the AC method to factorize this trinomial. So we could split up our middle term and try to find two factors that when we multiply those factors would get the product of A and C, and when we add them would get our B. But that is a lot of work. So the perfect square trinomial method is much easier. It's a more direct and convenient method that we can use once trinomial fits or meets three criteria. So let's look at those three criteria. So looking on this trinomial, we see that we have a minus and we have a plus. So let's check to see if our first term is a perfect square, if our last term is a perfect square, and the middle term is twice the product of the first and the last term. So a squared is equal to x squared. So we have x squared right here. So let's see, when we find the square root of both of them, so a is equal to x. So the square root of x squared is x. So x squared is a perfect square. Let's check our 100. So b squared equal to 100. If we find the square root of both terms, would have b is equal to the square root of 100 is 10. So we see that 100 is also a perfect square. Let us check our middle term. So we know that it should be twice the product of a and b. So we see that a is x, so it'll be 2 times x. And we see that b is 10, so times 10. So 2 times x is 2x, and 2x times 10 give us 20x. So seeing that all three of these criteria are met, all of them are true, then we can go ahead and factorize using the perfect square trinomial. So we know that when we factorize, it would be a. So our a is x, so it would be x. Based on the trinomial that we have, it would be the second one, so it will be a minus b all squared. So x minus, or b is 10, so 10 all squared. And that is our factorized answer, x minus 10 all squared. So let's look at another example. We are asked to factorize g squared plus 12g plus 36. The first term is always a perfect square. So a squared is equal to g squared. So when we find the square root of this, what will we get? So a is equal to the square root of g squared is just g. So we see that g squared is a perfect square, so we get g. We're going to look for our last term is also a perfect square. So I know that our last term is normally b squared. So we are going to find the square root of our last term and see what we will get. So b is equal to the square root of 36 is 6. So our 36 is also a perfect square. We know that our middle term is twice the product of a and b. So let's see if we will get 12g when we do that. So 2 times a is g and b is 6. So 2 times g is 2g. 2g times 6 gives us 12g. So all three questions are true. We realize, so therefore this is a perfect square trinomial and it fits the pattern of the first one, a squared plus 2ab plus b squared. Therefore we can factorize it. So therefore when we factorize, our answer would be bracket our a, which is g, plus our b term, which is 6, all square. That is our answer. All right, so here's the next problem. We're going to see if this fits the criteria as a perfect square to avoid the long working out. We're going to check to see if the first term is a perfect square, if the last term is a perfect square, and the middle term is twice the product of a and b, so the first and the last term. But before we dive into that, we realize that all three terms in the trinomial has something in common. Factor out a number, right? So we see that they have 4 in common. The highest common factor for the 4, the 24, and the 36 is 4. So we're just going to go ahead and factor out that 4 first, and that should make our working a little bit more easier. All right, so 4, if we factor out the 4, we are left with n squared plus 6n plus 9. So there we go. So we're just going to leave that 4 right here, and we're going to focus on the trinomial that we have in the bracket here. So n squared plus 6n plus 9. Great. So now we're going to investigate. So a square is equal to n squared, and when we find the square root, we see that a is equal to n. For last term, which would be b, is equal to 9. When we find the square root, we see that b is 3, so that is also a perfect square. And now our middle term, we know that it should be twice the product of a and b. So 2 times a, which is n, times our b, which is 3, that would give us 2n times 3, which is 6n. So we see that all three criteria are met, therefore we can go ahead and conclude that this is a perfect square trinomial, and we can factor it, open bracket, a, which is n, plus b, which is 3, all square. And don't forget to put your 4 that you factor out here. So it'll be 4 bracket n plus 3 all square. Now here we have a similar problem to the previous question. So we see that we can factor out something. So we're going to factor out the highest common factor, and then we go ahead to investigate if it is a perfect square trinomial. And if yes, we go ahead and factorize. For the coefficients, we see that 2 is common, but we also see that y is common to all three terms, so we can also factor out one of the y's. So when we factor out our 2y, we're left with 25y squared plus 10y plus 1. So we're just going to leave our 2y over there and focus on the trinomial that is in the brackets. So our first term, which is normally a squared, is 25y squared. So we're going to find the square root of that and to see if it is a perfect square. So a is equal to 5. Square root of y squared is y, so we get 5y. Therefore, our first term is a perfect square. Now let us check on our last term. So b squared is equal to 1. Now we want to see what is b. So the square root of 1 is 1, so therefore b is equal to 1. Now let us check on our middle term if it fits the criteria as well. So 2ab, 2 times or a, which is 5y, times or b, which is 1, and we'll get 2 times 5y gives us 10y. 10y times 1 will give us 10y. So all three criteria are met. Therefore, we can write this trinomial in the form. So let's go. Our a is 5y, and plus our b, which is 1, all square, and we write back our 2y that we had factored out before. So our final answer is 2y times 5y plus 1 all square. So here is our final question. And looking on this problem just as it is, it will be easy for us to say that no man, this is not a perfect square trinomial, because I'm seeing two variables here. This is stressful. So the first question is, can we factor out anything? So no, they don't have an x or a y in common, and there's not a common factor for 16, 40, and 25. Let's see if our first term is a perfect square. So we say that this is our a square. So our 16x squared is our a square. I want to find the square root of this. So our square root of 16 is 4, and the square root of x squared is x. So we see that our first term here is a perfect square. Let's check to see if our last term is also a perfect square. So it should be b squared, and it's equal to 25y squared. B would be equal to square root of 25 is 5. The square root of y squared is y. So we see that our last term is a perfect square. Let us check to see if our middle term is 2 times the product of a and b. So we have 2, a is 4x, b is 5y. Now when we multiply this, let's see what we will get. So 2 times 4x will give us 8x, and 8x times 5y will give us 40xy. So it actually satisfies the three criteria. Therefore, we can go ahead and write this as a binomial squared. So based on the pattern, it corresponds to our second trinomial, which is our a squared minus 2ab plus b squared. Therefore, we know that when we factorize, it will be a minus b all squared. So our a is 4x minus our b, which is 5y, and that will be all squared. That's it for today. Thank you for watching. Remember to like, share, and subscribe, and stay tuned for more educational content. I'm out.